Okay, everybody should be able to hear me and see what's on the screen. Um, okay. So if you guys can hear me, you can go ahead and ask a question, or if nobody asks a question, I will just start talking about stuff, I guess. Oh my goodness, somebody asked a question. Okay, got it. Cool. Yeah, so on the review problem, or which review problem, I guess I should say. And if this isn't coming through well, please just send a question saying that the quality's horrible or it's jumpy or whatever. Number 24, sure. And then I see this other question here too. Oh my goodness, there's questions. 24, 29B. Okay. All right, let me go to that. One second. Okay, so number 24 is this. How many kilometers per hour a tree. The front end of the car driver comes to rest after traveling 0.7 meters. What is the average acceleration of the driver during the collision? So the first thing to do, is look at we're given that the initial velocity is 90 kilometers, and we want to multiply that by 1,000 meters per kilometer, and by 1 hour is 3,600 seconds, so that we get an answer in, or so that we get something in meters per second. They also tell you that it compresses while it's traveling 0.7 meters. So the change in position is 0.7 meters. So since it's stopping, we know that VF is going to be 0. Seeing weird with the active inspire things. Never done this before. Okay, there it's back. Yeah, very good. Okay. So we know these three things, and we'd like to know the acceleration. So we're finding acceleration. So an equation that we know that has acceleration, initial velocity, final velocity, and change in position is Vf squared minus Vi squared is equal to 2a delta s. You can rearrange that and solve for acceleration, especially since you know that Vf is 0. That comes out to be pretty easy. You've got Vi squared, negative Vi squared, equal to 2a delta s, and so a is just going to be negative over 2 delta s. And you're accelerating in the opposite direction that you were moving. So if your initial velocity was positive, your acceleration is going to be negative, slowing you down to stop. So it should come out to be negative, so that seems good. So you just have to figure out what Vi is in meters per second, which, I don't know, what's 90,000 divided by 3,000? That's 30. So 30 squared over, yeah, it seems like it's okay-ish. I'd have to get a calculator out. It's a shame there's so much of a delay until you hear what I say, or else I could ask you guys to tell me what it is real quick. So 90 times 1,000 divided by 3,600 is going to give us 25. And here we've got 25 squared divided by 1.4, which is in fact 446.43. So that gives you the answer that they show here. G's is at, well, 1g, so 1g is just the acceleration of gravity, 9.8 meters per second. On the Earth, we're experiencing 1g. When you're in this car crash, you experience 45 g's, about 45 g's. It's a lot, and you've got to figure that much acceleration is probably going to hurt. So yeah, that's how you do that one. And the question thing is running a little slow, but we'll get through it. Done with that. To this, and then Emily, I'll do yours next about acceleration. Want to use positive and negative. So 20B, and if something about this one didn't make sense, let me know, and I'll go back to it. This thing's, but the other stuff is still there. So, well, where'd it go? Sorry, it's being kind of odd, like I said. Um, okay, well, while that's trying to come up, I'll grab 29 and paste it in. We're back to the original. This is so strange. I'm hitting the button to go over, and I don't know what you guys are seeing, but I'm hitting it and nothing's happening. Oh, it's there. It's just not changing. Okay, so you're probably seeing it, and I look silly because I'm not seeing it, but the screen isn't refreshing for me. Here, let me turn this off for a second, and then I'll turn it back on. See if that helps. It did not. So let's put this in. Okay, so a stone is thrown vertically upward with a speed of 12 meters per second from the edge of a cliff that's that high to reach the bottom of the cliff. So you can do that part, and we're looking at B. What is its velocity just before hitting the ground? So we know the initial velocity is 12 meters per second. So let's draw a little picture. Here's you over the cliff. Here's a cliff. The cliff is 75 meters high. And it's going to go up and then come down. So the initial velocity is going up, so we call that positive, but you'll see in a minute that it doesn't really matter. We know that the acceleration, we're going to say up is positive, right? So that means that the acceleration is negative because we know the acceleration of gravity is always down. So that's going to be negative g and negative 10. Well, actually, with this, they always use 9.8, so let's do the same. So negative 9.8 meters per second squared. And we know the change in position. So delta S, it's starting up here, and it's falling down 75 meters. So the change is going to be negative h, the height of the cliff, negative 75 meters. Okay. So the thing I don't know is VF, the speed down here. So I'm looking for that. So I'm going to use the squared minus VI squared is equal to 2A delta S. And since I'm going to where VI is, it doesn't matter if it's positive or negative. But also, you know that if you throw this up at 12 meters per second, when it gets back to where you threw it from, it'll be going down at 12 meters per second. So it's good that it doesn't matter because it, you know, it can't matter. So the equation wouldn't be true. So solving that for the final velocity, you get that VF is equal to the square root of 2A delta S plus VI squared. And the A is negative G, and the delta S is negative H, so the negatives cancel out, and we get 2GH plus VI squared. you'll find the final speed. And then since it's going down, you know that it'll be negative. So when you do a square root, you know the answer is going to be either positive or negative. So you're going to choose the negative one because you know it's going down, and we said down is negative. And if you put those numbers in, you should get 40. Okay. Let's see what we got. So can you review acceleration when to use positive versus negative? And then I've got, can you do a question like the ones on WebAssign where you drop something but you're already on a moving platform? Oh, where like the elevator's going up or down? So yeah, we can do that too. Function, and is it positive or negative? So, oh no. Many problems like this. Okay, that's better. All right, so basically you need to choose a direction to be positive and a direction to be negative for the entire problem, no matter what it is that you're doing. And usually that choice is pretty obvious, or you're told what it is. But when you're doing the free fall problems, you know, you could choose up to be positive or down to be positive. But for us, I think the best thing to do is to always say that up is positive. So if you're down here and you're throwing something up and trying to get up on this roof, right? So here's you. You're going to throw this ball, basically. So you throw it up, and hopefully it lands on the roof. And we'll ignore the fact that it would have to move over a little bit to do that. So you're going to say that up is positive. So anything that's down will be negative. But in this case, pretty much everything's up, right? The velocity, the initial velocity, is going to be positive. The change in position, so you're going up from down here to up here, so that's positive. The only thing really that would be negative, I guess if you found the final velocity when it was coming down, that would be negative. But the big one is acceleration, right? Because the acceleration is equal to negative g, because it's going down. And gravity always pulls down, so that'll always be negative g. And then when you do a problem, when it's time to plug in acceleration, you just plug in negative g, whatever that value is. So for us, usually that value is going to be 9.8 or 10, but maybe you're on the moon or on Mars or something like that, so different. But just work out your equation, and when you get to the part where you have an a and you need to plug in a value, you're going to put in negative 9.8 or 10 or whatever it is. So something a little different if you're standing, like we were before, on top of a cliff or a building, and you're throwing something or you're dropping it. So maybe we actually throw it down. So we give it an initial velocity that's down. Well, up is positive. So now you've got a VI that's going to be negative. You've got a change in position because you go from here down to here. So that's negative too. Right? You know your acceleration is negative. And your final velocity would also be negative. So everything's negative. That's why sometimes it's nice to say down's positive, but since it gets confusing for people, I would just say up is positive and make all those things negative. So I think where it's really a problem is when you have this change of direction. So we start with the ball going up, it reaches a peak, and then it starts coming down. So the velocity here, we've got positive velocity. Over here we've got negative velocity, and here at the peak, the velocity is 0. The acceleration is negative the whole time. So this is velocity, velocity, velocity. but all the time the acceleration is negative g. So on the left side over here where it's on the way up, we've got a positive velocity and a negative acceleration, so it slows down and eventually it stops. And then we're going to start going the other way, so the velocity is negative, since we said down is negative, and we've got a negative acceleration, so we're speeding up. So when we're talking about positive and negative, you can kind of imagine it like this. So here's 0 height, and maybe this is like plus 100, and then down here is minus 100 or minus 50 or whatever. So if you're heading in the direct numbers are getting more positive, then, and this would be, position. So if you're going in the direction where your numbers are getting more positive, then you're moving in the positive direction, so your velocity is positive. If you're moving towards the negative numbers, so here we're moving, if you take your pencil and you trace this, your pencil is moving towards the negative numbers. Even though it's not there yet, it's moving that way, so your velocity is negative. And then you also know the velocity is the slope of the line, and I can't really put a pin here, but if you can imagine holding your pen right there, and then letting your pen follow the slope of the line, it would keep turning like this, and it would get more and more steep. Right? So the velocity is getting higher and higher and higher, but it's always sloped down. So it's negative there. It's 0 here, and then it would be going up here. Right? These are positive slopes, these are negative slopes over here. So you can look at the slope, you can look at your pen is moving, and you can try to think about whether the velocity is positive or negative. But the acceleration is always down, it's always towards the negative numbers, it's always g. So, yeah. If there's any more questions about that, please ask them in the thing, and I will talk about it some more. Okay. So for this one, let me hold on just a moment. Okay, I'm just looking at your homework. So you're riding on an elevator, descending with a constant speed. So yeah, let's look at this. So while riding on an elevator descending with a constant speed of 3.1 meters per second, you accidentally drop a book from under your arm. How long does it take for the book to reach the elevator floor? 1 meter below your arm. What is the book's speed relative to you when it hits the floor? So you've got an elevator. Okay, everything's going weird again. Okay, here's you. And you've got this book, and the book's going to fall down. So the elevator is moving down with a constant speed of 3.1 meters per second. So are you, so is the book. Everything's moving down at 3.1 meters per second. So it actually doesn't matter. If it was accelerating, then that would make a difference. But since everything was already moving together, they might as well not be moving. So they're all going to start with the same initial velocity, so As far as you, the book, and the elevator are concerned, none of you are moving. So it's okay to just treat it like you're not. Now, you could also do the math for when they're both moving, and then you'll see that that 3.1 is just going to subtract away. If you think about the perspective of somebody standing down here on the ground and watching it all happen. So let's say it takes, well, we know that it's, the answer is about half a second for this book to fall. So in the half a second it takes for the book to fall, the guy on the ground is going to see the elevator move down, and the amount it's going to move down is 3.1 meters per second times 0.452 seconds. He's going to see you move down that far as well. He's going to see the book move down that far, plus some more because it's been accelerating. So the acceleration part is giving you a little bit extra. So these arrows, which I probably should have used a different color here. So all of these green arrows are the same length because you're all going to move the same amount in that 0.452 seconds because you all had the same 3.1 meters per second velocity to begin with. But the arrow in black is the extra distance the book moves because gravity is also going to accelerate it down. So you can forget about the fact that it was going 3.1 in this case. In the next one where you drop a camera out of a hot air balloon, that's different because the camera is going to hit the ground, not the balloon. Right? So that's a different situation. So how long does it take for the book to reach the elevator floor? 1 meter below your arm. So you know that the initial velocity is essentially 0. Right? You know that the change in position is going to be -1 meters. You know the acceleration is going to be -g, which is negative, we'll say 9.8 meters per second squared. And then you're looking for the time. So delta S is equal to VIT, but that's 0, times 1/2 AT squared. So that's going to be -1/2 GT squared. So we're trying to find T. T in, this is, we can call it -h, right? So I like to work with the letters more. I don't like to write in the numbers until I really have to. So you can see the negatives are going to cancel, so this is the square root of 2h over g. So we've got the square root of 2 times 1, it's easy, it's 2, divided by g, that is 9.81 meters per second squared, meters. So the meters will cancel, the second square goes up top, you take the square root of that, you get seconds, so that all works out. And the square root of 2 divided by 9.81 is 0.452. So that all worked out. Excuse me. Okay, what is the elevator speed relative to you when it hits the elevator floor? So same thing, everybody's moving at the same rate to start with. You're all moving at 0 according to each other. It's only the guy that is on the ground watching that realizes that that's not the case. You in the elevator, if the elevator didn't have any windows, you wouldn't even be able to tell that it was moving, except for the fact that it might be making noise or rattling. Until it accelerates. When it accelerates, you can feel that, but you can't feel constant velocity. Okay, so the book speed relative to you when it hits the floor, you would just be looking for VF in this problem, or you can use the time that you just found, either way. But I would say I would use the VF squared minus VI squared, and I know that VF is just going to be the square root of yeah, the VI is 0, so that's 2GH. And then when you do that, you'll find that it's 4.43. Okay. So that's one question, a different one. So I don't want to do the hot air balloon one. That's on your homework. You guys can work that out. But I'll do one similar to that. What equation do you use to do 28b, and why are there two answers? So we'll look at that. Okay. So let's say we're going to stick with a hot air balloon, but we're going to change it up a little bit. Oh, actually, I've got shapes. Hang on. There we go. It's a nice big green hot air balloon. Okay, so you're going up. And you're moving up, let's say, at a constant speed of 3 meters per second. And you realize that you have the car keys because somebody has to drive to wherever the balloon's going to land and get you. So you take the car keys and you drop them to your friend who's standing down here waiting to catch them. So the car keys, you might think, and according to you, this is what you'll see, that they're going to drop straight down to your friend, accelerating as they go. But what your friend is going to see, because your friend is sitting still, is that they're actually going to go at an initial velocity of 2.3 seconds already. So the balloon was moving up, you were moving up, the keys were moving up. So the keys are going to go up a little bit, they fall down. And your friend can still catch them. So you would have to figure out, if you wanted to know how long it was in the air, you would have to how long it was in the air, including the fact that it goes up a little bit. If you want to find out the speed when it gets down, you need to include the fact that it has an initial velocity. So you've got to work all those things out with an initial velocity of 2.3 meters per second. We're going to say that up is positive. We know that the acceleration is negative g, or negative, let's just say 9.8. That's what we've been doing lately. So, okay, and then let's say I do want to know how long it takes for them to get to your friend. So I'm looking for the time. And you would know that maybe you were already 10 meters away from your, so you're up here 10 meters. So we got to figure out how long it takes for it to do that. So we've got delta is going to be, I'll call it negative h, and that's going to be negative 10. Right. Okay, so I've got the change position acceleration via delta s is equal to vit plus 1/2 a t squared. And if we start substituting things, we get negative h here, we get vit, and we get negative 1/2 gt squared. So we know all these things except for t, and t is, it's a quadratic. Or you can Google it, and you'll see how to do it pretty easily. So you just plug in your numbers, and you would solve for t, either using the quadratic formula or letting your calculator do it for you. And then you'll find out how long it was in the air. There's another way to do it. You can figure out how long it takes to get to the peak where you know the velocity is 0. Figure out how long it takes to get there, how long it takes to fall down, and then add them together. So you can do that. If I want to know how fast it's going when it reaches my friend, well, I know that when it reaches this point again, it's going to be going down at the same speed it was going up at, right? Or I can just trust that this equation squared equals 2a delta s works, and just plug in what I know. So the initial velocity, 2.3. The final velocity is what I'm looking for. A is negative 10, and then just solve for VF. So you can do that as well. So yeah, hopefully that covers that question. But again, if I leave anything out, just ask me, and I can go back and we can talk about it more. So back to the review. What equation do you use for 28B? So there's two answers because it reaches that height twice. Once on the way up and once on the way down. Okay, got it, good. Oh, that was weird. Okay, so stretch this out a little bit. There we go. All right. You throw the stone directly up over the speed of 22 meters per second. So it's going to go up, hit a peak, come back down. At the peak, you know the velocity is 0. At 15 meters on the way up and 15 meters on the way down, we're going to be looking at it. So you know the initial velocity is 22 meters per second. The velocity at a height of 15 meters. Okay, so you're trying to find V right here, so we'll call that VF. And I know the acceleration going down, and that's negative g. And I know that this is my delta s. VF squared is equal to VI squared plus 2a delta s. Pardon me. So you'll find the square root of that. So VF is the square root of this stuff. And there's a positive and a negative for that. So when you take the square root, remember, whatever you got, it could have been positive 13.78, and then if you squared it, you would have what's inside here. Or it could have been negative 13.78, and if you squared it, you would get what's inside there because the negatives cancel. So there's always two answers that come out when you take a square root. Oh, by the way, when you do this quadratic, you have to choose the and it's doing it again. There we go. So when you solve for t, there's two answers, so you got to pick the right answer. And it's usually pretty obvious. One will be positive, one will be negative, or one will be ridiculous and one won't be. But yeah. Okay, so that's how you find the velocity, and then for b, how long is required to reach that height? Well, once you know the velocity, that makes it a lot easier. I, you know VF, you know A, and you're looking for T. So you've got VF is equal to VI plus AT. Is that to find T? Without that, you know that we're looking for 15 meters. So you know that delta S, the IT, plus 1/2 AT squared. And you can plug in your 15, you can plug in your VI, you know that A is negative g, and then you can find the time. So yeah. And if you put in the positive here for VF, well, I mean, this will give you, when you solve for time, this will give you two answers, right? So those are your two answers. At least it should be. And then over here, if you put in the positive number, you should get one answer, and the negative number, you should get the other. Okay. So it's really important to remember that with free fall, everything's symmetric about the peak. So if you're 15 meters high on the way up or 15 meters high on the way down, then you're going to have the same speed. It's just going to be directed in different directions. One will be going up, one will be going. Excuse me. Okay, so we actually talked about a lot of the stuff that I would have talked about. Free to ask more questions, but I'm going to go over just one more graph real quick. I'm going to talk about this a little bit tomorrow too, but you can get a preview. Come on, messing up. Okay, so we've been looking at a lot of these graphs. So velocity versus time. Put arrows here. Okay. So if you have a velocity time graph and you're trying to represent, then what is it going to look like? Well, you know that the slope of a velocity time graph is the acceleration. And you know that the acceleration, since we're going to say that up is positive and down is negative, is going to be negative g. So the slope of the line should be negative 8 or negative 10. So it should look something like this. But you can slide this line anywhere you want it. So maybe you started at 0 and you just dropped it. And maybe you threw it up with some initial velocity. Maybe you threw it initial velocity. So those are all possibilities as long as it has the right slope. Now, the other thing that you could see, and if they ask you this on a test, they might do it like this instead. So this is equally valid. Straight, almost, yeah. Because you're allowed to say, and we're going to try not to do it when we're solving problems, but you're allowed to say that down is positive. And if down is positive, then the acceleration becomes positive g, and the slope should go up. But either way, that's showing you a constant acceleration, and you know that free fall is constant acceleration. And yeah, either is equally valid. But this is what the graph looked this. Or, here, I'll do one in green again. Oh, that's what I wanted to do. Shapes. Green. So this would be a equals negative g, and then the black one is a equals g. So both are valid, it just depends on how you set up your coordinates. Is that purple? I don't think so. Okay. All right, any more questions from the 10 of you that are watching? I'm going to try to provide as much, assistance for you guys as I can. I know that, in class, it doesn't always come across the best. Address a whole bunch of people at once. This gives you a chance to get some more individual attention, even if it is just me talking to a computer. I can at least get your questions. But I encourage you to come in to the review sessions on Tuesday when we can sit down in person and go over things, or let me know pretty much any day you want to come in after school. I can always at least stay for half an hour and work with you on stuff, but a lot of times I can stay a lot longer than that. So please come in, get help. Make sure you're doing your homework and reading your book. And yeah, if you need more material, just ask me, and I'll show you where you can get some more stuff to do. And we'll make sure that you're as prepared as possible. Okay, study hard and get ready for the test. If you have questions, just email me, or you can stick around tomorrow after school and we can go over more stuff. All right, everybody have a great night, and I will see you tomorrow.